So, software architecture. We're talking about architecture today. It's actually a big topic, but we're only going to cover a small part of it. Architecture is means like how to design your software. Your software is the structural design of the software, aims to provide a stable foundation for complexity management and modular software development. So we want the programs, to work. We want it, I guess the main point is really that it's modular. Modular means that I can add things to it later. I divide it into parts, and then the parts talk, and I can add another part. That would be one idea. The architecture, what influence does it have? It tells us how the data will be stored and how it will be accessed. In other words, what kind of database you'll use, or will you use a database? What will the application consist of? What will there be the relationship between the parts of the system? How the system components will communicate, right? We'll learn about certain methods of communication, how you're going to communicate. Affects the ability to handle loads and performance of the system. In other words, if all of a sudden many people are using the application, the system should be able to be expanded in a way that it doesn't crash because a lot of people are using it. You should think about security, making sure that people can't hack it or that people's data is protected. How flexible the strong system will be and how it'll be able to recover from malfunctions, right? You might have, we'll talk about a term which is called graceful degradation, which means that as parts of the system break, it doesn't, all of a sudden the whole system doesn't break, but it just gets a little bit worse. It degrades instead of crashing. And then how feasible and convenient it will be to expand the system, right? Will it be easy to change it? So the most simple architecture is called a monolithic architecture, and what it's saying is that the program is one program. Actually, everything you wrote is probably monolithic, even though you may have classes. It's monolithic because there's one overall code. It's an application. It's a program. And all the different functions and services are built together. In other words, we have large application that includes all the functionality without any internal division. The app runs on one computer, also called one tier. In other words, it's a program on one computer. And what do we mean by without any internal division? I mean, obviously, classes are division, functions are divisions. We don't mean those divisions. We mean divisions that in a sense that any object can create a class of any of the classes that are there. There's nothing like there's no interface. If I want to call a function, I just call a function. I don't have to use some kind of interface to get to it. So monolithic architecture, what are the characteristics of it? Any small change in the code requires a process of building and deploying the entire system. In other words, we have to compile it again. If you change the system, you have to compile the whole system. You can't just compile part of it, which can result in prolonged downtime, faster running, and therefore used for the development of operating systems. Right. It has a major advantage, which is that it's faster. And therefore, like the Linux operating system is considered monolithic, because if you don't have to communicate through intermediaries, then everything will run faster. Easy to understand and implement when the system is small. It gets, obviously, as it gets large, it gets complicated to understand it. Difficult to divide responsibilities in code management between different teams, which can cause coordination. In other words, it's hard to say, if I have different sections of the program, I say you do this and you do that. Obviously, I can have you do this class, you do that class, but that's a small division. What if we want a large section of the program you do? So how do I know what that section is if I don't have any modules, if I don't have any divisions? A significant challenge in the area of scalability. Since all parts of the system are connected and integrated with each other, there is often a difficulty in increasing or decreasing the resources allocated to only specific parts of the application, according to demand. In other words, this means that in the case of increased load, it is necessary to increase the resources, memory, CPU power for the entire application, even for parts that are not required for strenuous activity. In other words, I have a whole, if my program is running slow, I got to give it a faster computer or a faster memory. Whereas if I had it in parts, let's say spread out on different computers, then one part that was having an excessive load, I could give just that part a faster computer, or make multiple instances of that part. We'll see other architectures that allow for that.
Can you explain why Linux is slow?
Why they decided to make it, or what makes it?
What makes it?
Yeah, because there's the kernel, and the kernel does pretty much everything. There's on top of the kernel, there's a shell, for example, which the shell interfaces with. Did you take my course in Linux?
No.
No, but there's a shell that interfaces with the kernel. So some people say, oh, it's layers. It's got layers. It's got 2 layers. You have a layer of shell which talks to the kernel and gives you back information. So it has some kind of layers, but since the kernel is so big, it's considered monolithic. It's considered that that's like there's no, you install it, you don't add like parts. You don't add.
So division is when there's a bunch of layers to operating.
For example, that's the thing. In a sense, it's hard to understand monolithic until we learn other ones, which is layers and there's another one we're not going to talk about, which is just modular. But when we talk about layers, then you'll see there's layers. But there is truth. The truth of the matter is in Linux there is layers, but the layers, there's not enough layers to be considered not monolithic. And if I say I have 3 layers and then everything and 99% of the program is in this layer, well, that's not really called layers. It has to be some kind of even division. Software architecture pattern. So this is just in general. I don't know why this is exactly here, but what is a software architecture pattern? This is not a pattern that you're talking about like singleton and factory. You learned those things, right? Singleton and factory. What course was that? You tried computer science? Oh, you tried this. Yeah, you did it there. Okay. So this is architecture patterns, a set of design decisions that address design patterns, design problems that recur in a variety of contexts. In other words, monolithic is a design pattern, kind of, but not really much of a pattern. The most patternless pattern. The pattern proposes rules and principles for organizing the interaction between defined subsystems and their functions. So we have subsystems, and then we define how they relate according to some pattern. Today, there are a variety of architectures suitable for different types of applications. The goal: reduce dependency between the components, improve maintainability, and promote code reuse. What do we mean by reduce the dependency between the components? That's the idea.
If you remove one thing, then everything else will crash.
Yeah, or if I change it, if I change the way it works, it won't affect anybody else, because it's kind of like if I change the engine in a car and I put a different engine in, the driver couldn't notice because he's using a different layer. What layer is he using? He's using the human interface layer, where he has a gear, he has all the things that he has, but then the lower layer can change because there's different layers. So here are some example of patterns, or I don't know, I use the word, I translated it badly. There should be templates, should use the same term, patterns. So these are the 3 that we're going to talk about: client server, MVC, and layers. For your enrichment, here are some more architectural patterns. So you don't. Client server. So you probably know this pattern, this idea. You have a server, you have different clients. A decentralized application with separation into 2 components, each with a different possibility. So here you have 2 components: the client and the server. The client, or the front end, all the processes and interactions that take place in the client's computer include display, user experience. These are not hard and fast rules, but in general, anything that happens on the client's computer is the client's responsibility. And usually those things are the display, filling out a form, maybe error checking for a form, access to operating system functions, and more. The client forwards requests to specific resources such as reading information, services, files. In other words, if I have a request, if I want to get some information, some actual real information, I got to go to the server. Here I can just do, I can arrange what information I have. The client will be more in charge of presentation. And the server will actually store the information. Server is the back end. It's responsible for business logic, data processing, database management, all the operations related to the remote computer on which the software runs. So basically storing all the data and manipulating the data, maybe querying the data, waiting for customer requests. The customer will request, it sits there and it's in a waiting state until there's a request. Receives the request from the customer and delivering a response with the required resource. Now, if he asks for something, I give it to him. So there's always a question of the division of labor here. It used to be that, like when the web first came out, almost everything was done on the server, and the browser just displayed it from you just sent text to the browser and just displayed it. Then came along. Then somebody said, "Well, there's two problems with this. Can anybody think what can either of you think of what would be two problems with that?" If I do everything on the server side, I do all the manipulation, and here I just send text, and he presents the text. That's the way the web was originally 20 years ago or more. Server might be working too hard. Right. Well, in general, the server gets overloaded. What's another problem? This is one other problem. It's not particularly related to the server. But you're saying there could be a bottleneck on the server. Where else could there be a bottleneck? No. Client is just presenting, just getting text and presenting it. There's a third part of the system. Server, the client, and there's one more part. The wire that connects them. So it requires a lot of bandwidth. It could be the internet itself it'll be slow. I'll have to wait for the data to come. I'm constantly requesting every time I need a new piece of information. If I can send me all the information once, and then manipulations I do, like let's say I want to sort by, I got all the flights to Venice, but now I want to sort them by price, or I sort them by airline, or sort them by something else. If I do that, if I would have to request him again, please send it to me now sorted according to this. Then a whole nother request would come in and I'd get all the data again, and I'll just present it. If the client is very dumb, all he can do is just get data and present it and request for different data, then that sorting would have to take place here. But nowadays, right, you can press sort and instantly it sorts. Who's sorting it? The client is sorting it. How is that done? With what language in general? What's the famous language for that? That's embedded in your web page? You don't know? Did you guys take a course on full stack programming? Did you take a class on web programming at all? No?
We did, yeah. I don't.
You did a class on web programming? What language did you?
Oh, no, we did it was called web programming, like the advanced one.
Well, anyway, it's called JavaScript. There's a language called JavaScript, which is embedded in the HTML that the server gives you. And then when you click on a button, the JavaScript will rearrange the. Did you take a class on what is it, programming languages for applications or something like that? You didn't take that course?
I thought the client's
No. The client is the client program. There's a client program and a server program. The server, we don't mean the actual physical server. We mean a program running on the server and a program running on the client. We have two programs and they work together as a team to give you the information you want. And the division of the labor, the division of labor between those two programs can vary, is what my point is. A client server. A server is a computer program, like I said, that runs on a remote server machine and is accessible from the user's local computer or workstation via the client. The server waits for requests to reach a specific port. The client needs to know the server address and the port where it is waiting for the request. Do you know what a port is? You know any of these things? Yeah. The server is in a state of listening for requests. The minute the request comes, he can receive it and give the information. Since a request from a customer may come at any time, the server must be always running, waiting for the request, as opposed to the client program, which the user terminates when he's finished. So the server is always there. It's kind of like I have to deal with like God, listening all the time. And you can pray and stop praying. He's ready. The minute you want to pray, he's ready. He doesn't have to get notified. Types of clients. So there's something called a thin client. I was looking a little bit about this last night, how much this is still used, thin clients. I'm not sure they're really still used so much. But they actually, I did come up with an example. I thought of an example. The netbook. Have you ever heard of a netbook? Or a Chromebook? You ever heard of a Chromebook when you what?
Yeah.
Yeah, you've heard of a Chromebook. What's a Chromebook? What?
It's a laptop like that's
It's a-
like Google.
It's right, it's a Google, it's an app laptop, yeah, I had it, it's like Chromebook. It's a laptop by Google, but it's not just a regular laptop, it's not as powerful as your laptops.
Right.
It's very cheap and it's very unpowerful. But it's good enough if all you want to do is surf the web and just because you don't have to do that much programming because the client side doesn't do that much. He does a little bit, he maybe sorts the data that you got, but he doesn't do too much. So a thin client is one that is only able to connect to the server, and the server is the one that manages all the user operations. It's a bit of a strict definition. That would be like a super thin client. In fact, I would really call it a terminal. There's another concept called a terminal. A rich client is one that performs all the interactions with the user and turns to the server only in order to retrieve and set data. In other words, if the client is doing a lot of labor, then it's called a rich client. If the client is doing very little, then it's a thin client. In the past, the use of terminals was common. These were like thin clients. They were connected to a mainframe computer and performed all the operations on it. But with the rapid progress of personal computers, they were pushed aside in the 1990s and gave way to rich clients, which reduced network traffic and server load because the client can do stuff. The development of the internet and its increased the bandwidth have brought the thin client back, and that's the netbook. Basically, I'm confusing two different things. One is the program itself, that could be called a thin client, and one is the hardware that runs the thin client. That's also could be called a thin client. Multi-client handling. To handle multiple clients, the server can manage a request queue or open a separate thread. In other words, how does the server deal with multiple clients? I think this is like one user, this is one program, these are all different programs. They want to get to the database. So the server creates a thread for each client as it comes. The client, and that thread is like a new program that can now access the database. So he has many threads running, well, each one for talking to the one client that he's assigned to. Now I added this thread pools. Thread pools, the idea is that you could set up ahead of time a bunch of clients that are all sitting around waiting. And as soon as a user or as soon as a client comes along, I give him one of the threads in the pool. So I don't have to create them when there's a request. I can create them ahead of time and they'll run a little bit faster. When there are several threads, there might be simultaneous data updates. So we'll have to deal with the problem of synchronization. Right? If he's changing data, if two are changing the same data, like if I buy, what happens if 6 people, I always wonder about this. What happens if 6 people try to buy a plane ticket? Let's say there's 6 plane tickets left. And 10 people all come along and try to buy 6 tickets. So they all get told, yes, there's 6 tickets. And they all press purchase, 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 purchase. You know, how does it get updated instantly? Because there's a communication lag. But I guess it's on. Okay. So how do you use the client server? So, as I said already, you know, email or online banking services or the World Wide Web or are using client server. Also, file sharing applications, game apps. Sometimes when you're gaming, if you have a special game app, it might be using. I mean, it's all World Wide Web. I don't know why we add World Wide. Everything is over the web nowadays. You don't have. It used to be that the truth is, before there was the web, you could still, like the bank manager, could still access the bank from his house without using the web. He would dial in. I don't know if you ever see the movie War Games. No, you ever saw the movie? It's a great movie from the late 80s, I think. It's about like some kid, like some computer genius kind of kid, who hacks into the federal government and he thinks that he found like a computerized nuclear war simulator. So he starts playing it as though it's a game. But it turns out it's not really a game, it's the real one. So he's like, he's about to start World War. They have to find him and whatever, they have to figure out how to stop World War II, World War III. World War, right. Applications that focus on real-time services like telecommunication apps are built with a distributed application structure. Right, I think what they mean is there may be multiple servers. So what are the problems with client server shortcomings? Insufficient server capacity can cause performance bottleneck, right? If everyone's trying to use the same server, you can slow down. A slower server can delay the operation of other fast servers. If you have multiple servers, let's say you have multiple servers working together, one could be slower than another, it might cause a bottleneck. Servers are usually prone to a single point of failure. If the server goes down, then I can't do anything. That's one problem. So we a lot of times have duplication of servers that provide the same service in order to achieve what I referred to before, graceful degradation. In other words, if I have a service that say provides me the weather report for my part of buying, I don't know, what would we use a weather report? Some kind of plane navigation system that tries to figure out how long it's when a plane is supposed to arrive, or it has what airport it should go to. Maybe it's a weather report. So if I have if one of the servers goes down, then all of a sudden I can't fly. I don't know what the weather is going to be over there. So I might want to have multiple ones. Server maintenance can be demanding and expensive task. Okay, you need to maintain the server. MVC. This is a second pattern. MVC is very famous. In fact, everything now pretty much everything is both server and MVC. The truth is, not really. Pretty much everybody uses MVC, and they use servers and clients. So we have this picture here, and we were just going to understand in a very simple way. The model is basically the data, the way the data is stored. What model? In the sense, why do we call it a model? Because in the data, you're modeling something in the real world. Like if it's a user account and you have his name and his address and his phone number, you modeled that entity in data, in a form of data. And then you have the view, the way you see it. And therefore I can change the view and have the model and the data be the same. Or reverse, I can change the model, I can add something to the model. And doesn't necessarily mean I'll even see it in the view. I can add extra information in the model. All of a sudden I change the model. They're just, I decouple them. That's what we mentioned before. We want to decouple them. You know what coupling means? Like connecting. So I want to deconnect them. And then I have the controller, which here it says that the view, when a view wants to change the model, he doesn't talk directly to the model. He tells the controller, pass this information to the model. And the controller can therefore actually change the data. He can filter the data. I remember as a programmer, I sometimes didn't know where to make, let's say I want to change a certain date. Let's say I want to put the date. Let's say he updates, he logged in. Let's say the user logged in, and I want to keep a record of every time he logs in. Okay, I want to keep a record every time he logs in. Who should update it? Now, who should the date? He's not going to type in the date. I know the date. So I just want to update in my model that he logged in on this date. I'm keeping track of all the logs. So in my model, I have a log of all the times he logged in. So who should do it? It could be either the controller or the viewer. Both of them have an access, can figure out the date. Both of them can put that information. It's not always clear who should be doing it. Sometimes the controller creates information, sometimes the viewer. Separation of concerns between the business and the user interface. In other words, I guess the business is really in the controller, the business is in the controller, the actual data is in the model, and the view is just to view it. So the model, the MVC template describes a technique for dividing the application into three parts, as we said, which are connected by an event-oriented loose coupling. In other words, they're loosely connected. In this way, the interdependence between the user interface and the rest of the software is reduced. I can change the user interface without changing that, or I can change that without changing the user interface. And the different parts can be developed independently. I can have one team doing the view. In fact, you usually have a team doing the front end and a team doing the back end. The back end would be the controller and the model. In addition, it is easier to maintain software as well as to reuse the separate parts of the application. I could use the same view on a different program, perhaps. So the model is really what I said is a representation of the information which the application operates on. The data and access to them are included in the model. There'll be some kind of access to it, like an SQL query. Represents the data the business manages. The data calculates the process, what is needed and responds to requests from other two components. The view converts the model into a view. The controller links the display in the model. Okay. If you have questions, you should ask them. So the behavior can be implemented in different ways. The controller logs or observes for some kind of event. When the event occurs in the user interface, then the controller will now be in charge, and he'll, let's say, notify the model. Perform a reciprocal action in view with the interface. For example, clicking on add product to cart. That's in the view, but that's got to eventually get to the controller and the model. The controller registered on the display is monitored and activates a service defined in the model to reflect the action performed. For example, adding the item to a shopping cart. Okay. So the user interacts with the view receives the data, the controller processes the data, updates the model, and then the model is changed, then updates the view to tell him, okay, I've received it and the model has been changed. And now the view can go and request the data from the model. So actually the view can actually get data directly from the model, as we saw in the picture, as we see in the picture here. Controller updates the view and the view renders the updated version. Here's an example. So here's a model. Well, this is a model just as, what is this? This is just a data structure, right? A class. What is missing here from this picture? This is the model. Here's the view. Why is this a view? Well, because we say print line. Okay, it's very primitive kind of view. And why is this a controller? It updates the view. Display product view. It gives it the model's name and the model. It goes to the model and gets the price and gets the name and takes the view and updates it. So he's like in control. But here is the actual view. When he gets that name, we don't display product, right? So we gave him the name and he'll write he'll add the word product. You see here, I'm just giving him the name of the product. I'm not telling him what to write in front of it. This could be in English or in French. And this could be in English or in French, but this is the actual name that I'm getting from the model. and I'm calling the view. There's still one thing that's sort of missing, which is like, how does this model actually write to the database? Okay, that's a very simple version of control model view without actually writing to a database, though, just creating classes. Here you see kind of the main, where I guess this is C#, yeah? This is C# or Java. Okay, when not to use the MVC design pattern. For small apps with limited functionalities, no need to get into all this complexity. It's very small. Real-time applications may not work well for real-time because it's going to slow things down. You have to communicate through stages. Right, monolithic would be better. Tightly coupled UI and logic. If the UI, the user interface, and the business logic are closely linked, this pattern might complicate things further. Why is that? The user interface and the logic are closely linked. The MVC might complicate things further.
Well, it's all, I was writing something that's
But it's two parts.
closely linked because like it's like tiny mistakes that was there.
No, closely linked means like
What do you mean by closely linked?
that the logic that they're both working, they're working on a logic together. One does part of the logic, the other does
Maybe
another
like
part.
the person using it misunderstands something.
Maybe there's two different programs. I'm not sure why.
Like
You'd have to have a good
like-
example.
Right.
I don't think it's really said, and I can't think of a good example of why, but tightly coupled user interface with the logic. I mean, that's what I was saying before, that sometimes you don't know where to do certain logic. Should it be in controller or should it be in the user interface? It's always a question. Limited resources for small teams or those unfamiliar with MVC, it can be confusing to work in this way. Because again, you never know where to do the logic. When to use it. Things with many features like e-commerce sites, like Amazon. I think it was actually primarily promoted by Amazon, this whole pattern. It helps organize code and manage complexity. Frequent UI changes. In other words, I want to change things. I can actually, the UI can talk with the view and not even talk to the model all the time. He can just directly talk to the view. I mean, it's kind of assumed here that, you see, where is all this stuff taking place? Where are all these things? Are they on the client side or the server side? Obviously, the model has got, the model has to be at some point on the server. The view is usually on the server, and the view, they're all on the server. All of these three are on the server. When I create the view, then I can pass it to a client once I have the view. The view part is to create the view. Advantages. It makes it easier to work on each part separately. Usually you'll have a team that deals with the view and another team that deals with the model, for example. And maybe usually the person who deals with the view will also deal with the when the company that I worked at, I did all three, so I don't know. It helps developers add new features smoothly, makes testing simpler, allows for better interfaces. Overall, MVC helps keep everything organized and improves the quality of the software. The defined communication flow ensures that each component is responsible for a specific aspect of the application's functionality, leading to a more maintainable and scalable architecture. In other words, I can add things to it, I can change, it's easier to maintain it, to change it in the future. The disadvantages of MVC. The transfer of information between the model and the display can lead to contamination of a model with matters that the view should be handling. In other words, it can be misused. Sometimes I can have that the model is maybe doing some of the logic. The view and the model are tightly coupled. As a result, feature requirements of the view can easily drip down to the model and pollute the business logic layer. In other words, it basically, I think all these things are saying it's hard to distinguish sometimes what is view and what is controller, for example, or what is model. The view is monolithic and usually couples tightly with the user interface framework. Thus, unit testing the view becomes difficult because you can't use the view unless you also have the UI. So you have to test them together. Okay, layers. Another method is layers, and you can have as many layers as you want. So they call it N. I didn't write these slides. The woman who wrote these slides, she calls it N layers. I mean, that's what it's called. But what it means is you can have as many layers as you want. Each of which can be developed independently. Each layer has its own responsibility and level of abstraction. So you have responsibilities for each layer. You probably learned the 7 layers of ISO, the internet.
Yeah.
So why do we have layers there? So that one layer will complete a certain job, and I can assume that if I'm on a different layer, that's already been done, and I can use the lower layer to, and I don't have to worry about the things the lower layer did. I can just ask him for. I can ignore the things that he does. Each layer has its own responsibility and level of abstraction. Splitting the layers is a way of organizing your application. The layers should be separated so that the change in one layer will not affect the layer in another. Each layer calls the layer below it. I emphasize that line because that's basically the difference between layers and thing we're not learning, which is just components. If you have components, and any component can call any other component. If you have layers, then there's a hierarchy. The lower layer doesn't know about the existence of the higher layers. The lowest layer, he only knows, like if he's dealing with the hardware, he doesn't know that there's anybody else. He knows there's one layer above him, and he provides functions that can be called, and he can supply data or information or something. He can supply something to the layer above him, but he doesn't know anything more than that. He knows the layer below him and the layer above him. He is like servicing the layer above him and requesting things from the layer below him. That's it. Each layer calls the layer below it. The popular framework, so I guess programming environments use this approach. Fine. So here's an example of a layer where you have a database, and then you have a data access layer, the logic layer, user interface layer, and all that's the application. So here's just, I mean, this is very similar to the MVC in a sense. This is kind of the model, view, and control. Kind of. It's not really the same thing. This is
What's different?
we're not gonna. Why is it different? Well, the main reason why it's different is because there could be more layers. But here it's just we only see 3. But you could divide it. You can think of it as similar if it's just 3 layers. But the real difference is that that this is an application. Well, yeah, there's also an application. Interesting. Yeah, it's just that's just a way. The MVC is kind of like layers. It's kind of similar to layers. Most common layered architecture is the 3-layer, which is the client interface, system logic, and then the data layer has just these 4 functions: create an entity, request the entity, change the entity, or remove the entity. And they have this acronym called CRUD, which, there might be a bad question on the exam that says, what is CRUD? And then you have to say that. Kind of silly question, in my opinion, but you could ask, that's the kind of questions they might ask. I mean, because, I'm not saying they are, but I'm just saying that's the kind of question they might ask because, like, taught that. Can't say we didn't teach that, but it doesn't mean anything. Just an acronym for the things that you would do in an example of a layer. So here's 3 layers in one tier. When we say one tier, we mean one computer. So one computer with 3 layers where you have all layers can be written on the same computer and in the same language and communicate with each other through interfaces. Replacing a certain layer is done without touching other layers at all. Notice we have a defined interface. So for example, here, this is, what did we say? Database layer, data layer, business layer, presentation layer. That's what the P stands for. Presentation layer. So here's our presentation layer. This is it uses the API. You know what an API is? We'll talk about an API. Have you heard that term? Application Programming Interface. It's just the way it's defined protocol or defined method for interfacing, for using another program or another program. Because every time I create a layer, I have to create an API. Here's the API. When I want to communicate, I have to talk to the API. The API will then understand what I requested and give me what I want. He'll actually go to the data, for example. So what does this say? Namespace, business layer API, namespace, business object, namespace, business layer implementation. So I use the API to get to the implementation. The implementation then may call the implementation may call the API of the lower layer. So each layer has an API for defining how you can request things from it. But the actual behavior is in this white box. So 3 layers could be split onto 2 machines. One option is the logic and the data is on the server, and in the client, you could have the display. Another option is in the client, you could have the display and the logic, and the server just the data. Okay, you can divide it up like that. That would be 2 tiers because we have 2 machines, but 3 layers. Here, the client sends a request. The middle layer processes the request. The server actually responds to the data. The middle layer returns, and the client gets what he wants. Okay. Advantages. The simple structure and separation into layers simplifies the development and maintenance. Right. It's easier to develop it if I know what each layer does. I define each layer, and I give each layer to a team to do. And I define for them the inputs and the outputs. What are you supposed to receive? And you come up with the API. I can even write for them the API, and then they just have to program it. And if I change what one layer does, how it does it, I don't have to change anything else. I can have the same API, but let's say, for example, I have an API that says, this is how you request a sort. So I request this sort to sort this data. Now, one time I used merge sort, another time I used quick sort. So the implementation could be with quick sort or merge sort or bubble sort, but the API is constant. This stratification encourages modular development so that each layer can be developed, tested, and maintained separately. Reuse. The layer can be used by different layers on top of it. For example, if we have 2 different display layers, we could have 2 layers of display, each one using the previous. Disadvantage, performance overhead. Each layer adds its own level of abstraction and processing time, which leads to a lag. The more layers you have, the slower the program will go. Because in order to get something, I got to communicate with another part. I can't just do it directly. If I want to finally get to the lowest layer, I got to go through all the layers. I can't directly circumvent and go straight to the bottom layer. The need to switch between all the layers in order to make a request can be inefficient and not suitable for systems that require high performance or real-time performance. Complexity in simple, even for systems that are very simple, the architecture is not suitable because it is too complex for them. The disadvantage of overhead of a layered management is greater than the benefit of using it because we're adding complexity to a simple application. Rigidity, when there's a change in the system, sometimes the change requires updating several layers. And then this is my favorite one, difficulty in cross-layer optimization. The use of layers does not allow software optimization. So there's this concept called cross-cutting concerns, which is like there could be a certain concern that involves all the layers. For example, security. I want to have security in all the different layers. I don't want just in one. Who's going to handle security? The first layer, the second layer? So the answer is all the layers should deal with security. What about doing things quickly? Who should be in charge of making sure that everything is efficient? All the layers should be efficient. There's certain concerns that affect all the layers, and therefore, I can't have one person doing. The one person who's in charge of security would have to understand how all the layers work. Dependency management, managing the dependencies between the layers can be especially complex. What if A uses B and B uses A? It's maybe hard to determine which layer goes on top of which layer. What are some uses of it? Things that do more than just CRUD. Quick app building allows you to work on each layer. Right. You can do things fast. These are really advantages, otherwise uses. Applications requiring stringent standards of maintenance and testability. You can test each layer independently. Suitable for teams of inexperienced developers and limited knowledge of architecture templates. Okay. Summary. So I don't know why I'm not sure I understand if I agree with this, but here one-tiered architecture could be monolithic. It doesn't have to be monolithic. We could have MVC on one program. One tier just means one computer. All application components, presentation logic reside within a single program or unit. Simpler to develop initially, particularly for small, it becomes increasingly difficult to maintain and scale as complexity grows. Right. That's just monolithic. I think this is monolithic on one tier, but monolithic has to be on one tier, right? You can't have monolithic on two computers. There is only one tier. There's only one program. When you have layers, you could separate them onto different computers. Two-tiered architecture, client server. So client server by definition is going to be two tiers. That's what she means. I would have done it the other way. It should be like this. Monolithic is by definition one tier. Client server is by definition at least two tiers. Divide the application into two parts, and one talks to the other. 3 tiers. Separate the application into presentation, application, and data tiers, for example. Provides the greatest level of separation, promotes scalability. So fine, you could have that these 3 levels, the data and the logic and the view could be on 3 separate computers. Not necessarily, but they could be. So what languages are used for these things? Usually the presentation is done in JavaScript or any of these other examples. Logic is usually done in a language that you guys know, like JavaScript, could be JavaScript, like C# or Ruby. And the data tier is obviously going to be like with SQL or NoSQL, some kind of way of talking to the database. Okay. Almost finished with this section. In this architecture, we run software in various physical locations, right? We have n layers and n tiers. In other words, we have many layers and many different computers. Each computer could be doing a different layer. Here, the division is physical. The N layer and N tier are related but different. The layering is a logical division, whereas the N tier, which is the physical division. The N layers, all layers can be written on the same computer, possible to do all on the same computer, and in the same language and communication with each other through interfaces. But they can also be run on different computers. So you can decide which layer and how many layers will run on which computer. And then you have to have a communication system that's in language independent. For example, HTTP. Just text. Each layer can be written in a different language and a different technology, and can be used to link the layers. The layers will communicate with each other via some kind of API, which is going to be a text-based API, like sending messages. We're actually going to do that in the next section. When running layers in various physical computers, it's necessary to use appropriate communication protocols and technologies for data transfer. Okay, 3 tiers are equivalent to 3 layers if each layer runs on a separate physical computer, right? So 3 tiers and 3 layers become the same thing if they're on separate machines. And as if each layer is on a separate, if you have 3 tiers, then if you have 3 layers, then you essentially, and you have 3 tiers, then it starts to differentiate what's a tier and what's a layer. So here, example of N tier and N layer. Here you see that we have a first tier, a second tier, and a third tier, but inside the second tier, we can have many layers. That's the whole point of this thing. We can say user interface and presentation application, domain model, persistence, all these things are layers, but they're all on one computer, one tier. And then the third tier is just the actual database. All right, that's it for architecture. We'll take a break here, and then we'll finish. The other slide is very short. Okay, so now we're talking about a new topic, which is microservices. And SOA and API, kind of. Okay, what is well, we'll see what we'll go through. So here are our topics. Nice little picture here. This picture shows that every service that you may have has its own API. Well, if you have any questions, you can ask them, but we'll get into more detail. Here's the basic, here we already talked about monolithic. SOA stands for service-oriented architecture. That means you divide your program into services and you put them onto different computers, and you communicate, the computers communicate between each other. Microservices simply means that you have smaller services and more computers. Of course, it doesn't have to be separate computers. You might not have, how many is this? 4 times, you might not have, this is 16 computers. You might not have 16 computers. You could actually have 16 services on 5 computers. But they would still be different services in a sense like this. We have to make the distinction between a server and a service. Or even like this, a logical server and a physical server. I could have a physical machine, which I call a server, and on it I could build several servers. A web server, a mail server, some other kinds of servers. They're all individual server programs. They're essentially a program that runs but functions as a server in the sense that you have a port, you can connect to it, you can get information and retrieve the information. So we're back to the monolithic. We talked about it already before. Monolithic advantages. What's the advantage of monolithic? It's simpler to development and deploy. It's lower complexity in terms of data consistency and transactions. Now, there's no transactions. Data consistency, well, it's just one program. So all the data, they're not going to have different data on 2 different machines. There's just one machine, and it's all the data is, nobody else is going to be affecting the data. Unless, I mean, you could have multiple threads, but it's easier to synchronize between threads on a single machine than between separate service programs. Better speed and efficiency, it's faster. Okay, so here's monolithic. You have one computer, you have your database, you have your data layer, your business layer, maybe your view layer, and they're all communicating with the database. The database is not gonna be, I mean, it could be inconsistent, but you can use things like semaphores, like we learned in operating systems. And you can mutexes to make sure that different threads don't write at the same time. You can't do that if you're on different machines. So this is service-oriented architecture. And is essentially a collection of services. Okay, so we have a collection of services. Services, which is like I said, you can have different like servers that communicate on a port. Each one on a port, it could be on all in one machine, it could be on many machines. Services function as the building blocks of the application. So here the idea is that the service is something big, like it does all your billing, or it does all your credit card communications. CRM is, you know what CRM is? Client, something management,
Relation.
client, what?
Probably relation.
Yeah, relation management. It means like keeping track of like, is this guy, how many times does this guy come to our site? Is he a member? Is he not a member? Is he a premium member? All that stuff. That could be a whole service set of services that we can now use that. Let's say we write another program for, let's say this, somebody asked us to write a program for, you know, some kind of selling pet food. And somebody else asked us, a gambling site asked us to write a website for him. So we can use the same CRM section for him. I mean, we just have to make another copy of it. But we have a whole suite, a kind of a suite of services that are on a certain server, and we can plug them into this program or take them out. The billing, order management. And then the clients can, what is ESB? An enterprise service bus implements a communication system between mutually interacting software applications in a service-oriented. So we have this software. What is the purpose of this software? This will be like this will be the gambling site, and the gambling site will use our CRM, and then we'll make another version of this using the same CRM for our selling pet food site, and it'll have a different ESB, which will communicate with the same with a duplicate of these, but it'll be a duplicate of the CRM, let's say, but a different ESB, because it's one suited for selling pet food. Because the clients don't want to are not going to communicate directly with these inner workings of our services, these inner services. So we have building blocks of inner services. Now, what about, now we have a picture of monolithic versus microservice. So here's our monolithic again. And the idea here is, here we have a user interface which talks to this program. Okay. But here we have a microservice which does a certain finite task and has its own database, another microservice. Each one have their own defined task, and this user interface can communicate with any of them. We didn't yet see why this is so different from this one, but hopefully I think I give a better example. Microservice definition. Microservices are small-scale stateless services that have a single responsibility. They are combined to create applications. So if I'm doing my navigation application for airplanes, and I want to know the weather, I want to know the weather in a certain city, so I have a microservice called Get Weather or Report Weather, and that will be a service, and then I'll have another service called like compute distance or compute best route between, I give two cities and it gives me the best route. Just a very defined thing. It's not, and those are also the building blocks of my program, but it's not that I have a suite called CRM or a suite called everything to do with navigating a plane. I have little discrete functions. And now the thing about these microservices is I could have 3 servers where on all 3 of them I have a weather service, and all 3 of them I have some of these services. I could have 1,000 computers, and on 20 of them I have these services duplicated, and on other 20 I have other services. So I can have complete logical disconnection between the machines and the services they provide. I can have multiple copies of the same service. So what does it mean stateless? Does anyone know what stateless means? Well, it stores some information, but it doesn't store state information. What would that mean? So what does that mean? It doesn't store state information. For example, give me an example of state information. Where they
Like where they are in the process, maybe?
yeah, exactly, where they are in the process. In other words, for example, my weather, when you tell computing the weather is when I ask for the weather, it doesn't matter whether I just asked for it 100 times or I never asked for it at all, it's gonna give me the same response. I'm not gonna keep track of how many times, oh, if it's the third time, then I'm gonna give you a different response. That would be stateful. What if I want to send state, if I want to have state anyway, if I want to. If it's stateless, if it's, let's say I have a stateless service, how could I keep it stateless, but somehow do a workaround and get state out of it?
State in the sense that it stores information.
And it gives different results depending on my request, depending on the state I'm in my requests. Depending on whether I requested it the first time or if I moved along in the process and now I'm at this point in that. How would I get it to respond differently? Anyway, it's like a trick question, but how would you work around statelessness and still get some kind of state response? A response is based on my state. I want a response that's based on my state without it keeping track of the state.
That's a bigger system, really good, but I don't think it's.
I'll say, listen to what I say, how I say it. I want to get him to give me a different response based on my state without him knowing my state, without him keeping track of my state, without the server keeping track of my state.
Because they don't.
No, I'm the
I
client.
mean, have the microservice on a lower level, maybe?
Just have the client send the state as a parameter.
I
I want to know the weather and my state is 6. My state is 7. Whatever current status I'm in, I'll send it to you.
thought it doesn't.
Then you're still stateless because you don't care. You don't keep track of the state, but you'll give a different response. If you give me your state, I'll give you a different response. Hello. You understand what I mean? So I'll still get a state, a response that reflects my state, but not because he knows my state, because I told him, but because I told him, I passed it on. We can pass the state along to the other side. Why do we want it to be stateless? Why do we want our microservices to be stateless? It has to do with something I said about having 20 copies of them. Like I might have 20 services I have 100 different machines, and on 20 of them I have a service called Get the Weather. And on the same 100, I have 20 services that give me the best route between 2 cities. Why would I want them to be
It works
stateless?
much faster if it's statements.
Okay, it works less to check, maybe not, but okay, that's a possibility. What else? Can you think of anything else? Anybody?
Like from the server side or the user side?
No, if I'm building this architecture, why did I decide to make it stateless?
Easier.
No, it's because if I have, like I said the hint was that they have 20 different, on 100 machines, I have 20 different copies of this service called Get the Weather. I want to, let's say one crashes. I want to be able to go to another one. I want to be able to, each time I request, let's say there's a load balancer. And sometimes he sends me to this server and sometimes to that server and sometimes to another server. If it would be stateful, then I would want to go back to the same server that I had previously been at. Once it's stateless, I'm free to use any of the services. If 10 of them fall, or all of a sudden I see that lots of people coming to the website and I need more, everybody in the world is requesting weather, so I need to create on the fly, I'll create a whole bunch of more servers that do weather reporting. Now, the guy who asked for the weather before, when he asks for it now, he'll maybe get a different server that didn't even exist when he asked for it the first time. So if I need to keep track of state, then I would have to keep him on the same server every time. And that would be and that would make things more complicated, and it would be a problem if the server crashed, if I brought the server down. It could be, what if I have 20 servers, let's say the other way around. I have 20 servers, and all of a sudden I see that nobody's coming to request the service. So I say, why waste all that money? Because I didn't teach this, but there's a thing called, you know, AWS, Amazon, you pay for servers by the hour. So if all of a sudden I have a lot of load, I bring up 20 servers. Now all of a sudden I see that there's no load, I bring down the number of servers to 2. Now it could be that I was on a certain server and now it doesn't exist. So now I'm gonna go to a different server. So because it's stateless, it's not gonna affect me. Because there's no information on him. He just knows to receive the request and give back an answer. The CRM example that we saw in service-oriented architecture would be stateful. It would be a whole suite. It would take care of a lot of information from him. Take a lot of facilities from them. These are completely independent with their own databases, right? Each server had its own database. Microservice architecture example, photo printing. This is, yeah. So I might have, for example, a mobile app, and then this is who I communicate with. But I'm not going to communicate directly with the services. I communicate with some kind of API gateway or some kind of software. And I say, for example, I have services like to register, to log in. Authentication is just to log in, to check my user name and password. All it does is just let me log in. It now gives me by the way, how am I going to do an upload? If there's no state, here, I have a question for you, difficult question. If I'm not keeping track of state and I've already authenticated, now I can do upload. But if I haven't already authenticated, I can't do upload. But if I'm not keeping track of state, how will I know if I've already authenticated or not? You hear my question? If authentication is an independent state that just happened, an independent activity, I authenticated and told me, yes, you're in. But now, when I go to upload, when I tried to go to upload before, it didn't work. Now it's going to work because I logged in. Why would it work if it doesn't keep track of state? Upload is stateless. Doesn't know that I've logged in. How can that possibly make sense? No idea. All right, we'll think about that. You think about that. Characteristics of microservices. They are self-contained, implementation independent, and independently deployable. Microservices communicate by exchanging messages. They have lightweight protocols. Here's a summary of some differences. Microservices focus on small self-contained services. Oh, this is the aspect that we're talking about. Architecture focus. The focus is on reusing and integrating services across an enterprise. Uses enterprise level protocols like SOAP. So SOAP is well, we'll see. I don't know if we're going to see an example of SOAP, but SOAP uses for example, it has security features. Whereas here in JSON and REST, we have no security. All right, all that we're done. One slide here. Yeah, we're done. I mean, I can teach you more things, but that's all they need to know in the exam. So I'll stop.